So in our last section, we were graphing simple quadratic functions. In this section, we'll be graphing the full quadratic function. So remember, the full version of our quadratic standard form is y is equal to ax squared plus bx plus c. And you remember, each of these different coefficients has a different impact on the graph. So a, remember, determines whether it opens up or down and how wide or narrow it is. B is related to the x-coordinate of the vertex, and C is related to the y-coordinate of the vertex. We're going to be, so again, our learning objective here is to graph general quadratic functions, and our key vocabulary is minimum value or maximum value, and that is always related to the vertex. So if our vertex is at xy, the minimum or maximum value will be the y-coordinate of the vertex. Okay, because this is what determines how high or how low our graph will go. If the quadratic function opens up, it's a minimum value, and if it opens down, it's a maximum value. So again, we're graphing a quadratic function. It's going to be a parabola, right? That's for sure. We know it opens up if a is greater than 0, meaning positive, and opens down if it's less than 0, meaning negative. We know it's narrower when the absolute value of a, the leading coefficient, is greater, and it's wider when it's smaller. We know it has an axis of symmetry that goes through the vertex. Now, this is a new piece of information. So in standard form, the way to find the x-coordinate of the vertex is to use this formula that the x-coordinate of the vertex is the opposite of b over 2 times a. So we're going to use b and a in order to find it. Okay? And once we know where the x-coordinate is, then a vertical line through that is where our axis of symmetry is. And the y-intercept is always c. Okay, the y-intercept is always c. Okay, now in our simple functions, because we didn't have a b value, our x-coordinate of the vertex was always 0, because you can see if you put 0 in for b, that makes the numerator of this fraction 0, and so it's going to be 0. And so then c was always the y-coordinate of the vertex, but it was also the y-intercept. Okay, so let's look at working with the axis of symmetry in the vertex. So in this case, a is equal to 1, b is equal to -6, and c is equal to 11. And for me to find the vertex, and I'm going to do that first, the x-coordinate of the vertex is the opposite of b over 2 times a. Well, that's going to be the opposite of -6 over 2 times 1. So negative times negative becomes positive, and 6 divided by 2 is 3. Once I know what the x-coordinate of the vertex is, I'm going to plug that in. Y is equal to 3 squared minus 6 times 3 plus 11. So this is going to be 9 minus 18 plus 11. 9 minus 18 is -9. -9 plus 11 is 2. Y is equal to 2. So my vertex is at 3, 2. Okay, once I know that that is there, my axis of symmetry is always going to be x is equal to the x-coordinate of the vertex. Okay, so these values will be the same. Okay, and this is the answer to their question of the axis of symmetry and the vertex. Okay, if we want to graph, we're going to again locate first the vertex. My x-coordinate of the vertex will be the opposite of b over 2 times a. So b is 4, so the opposite of 4 over 2 times a, which is -4, 2 times -4. So that's going to be -4 over -8, which is 1/2. Once I know that this is 1/2, I'm going to plug it in to find the y-coordinate of the vertex. But right now, I know that x equals 1/2 is my axis of symmetry, right? So if I went ahead and put this in, actually, let me put in a coordinate grid here. And then I go ahead and put in my axis of symmetry, x is equal to 1/2. I'm going to go ahead and go by, I'm going to use 2 squares to be 1, because that's going to make my life just better. Right? And if I'm doing that, typically if I'm doing that on the x-axis, I'm going to do the same thing on the y-axis. Okay? To find the y-coordinate of the vertex, I'll have the opposite of 4 times 1/2 squared plus 4 times 1/2 plus 8. Well, 1/2 squared is 1/4 times -4 is -1. 4 times 1/2 is 2 plus 8. So y will be equal to -1 plus 2 is 1 plus 8 is 9. So 1/2, 9. Okay, so unfortunately, because I've gone by ones here, I've got a little bit of a problem getting this to fit on my graph. So I'm going to retreat, and I'm going to make this be, there's my axis of symmetry at 1/2. I'm going to go ahead and make these ones so that I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 here on my graph. So that's my vertex. My vertex is at 1/2, 9. And I know it opens down, but I'm going to choose values of x that are near my vertex. So I'm going to choose 1 and 2. And when I plug 1 in, 1 squared is 1 times -4 is -4. 4 times 1 is 4. So this will be 8, right? -4 plus 4 is 0 plus 8. So right there I'll have 8. Now notice, I'm 1/2 away from the axis of symmetry to the right. So if I go 1/2 to the left, I will have a point as well. This all matches up because we know this opens down, and we know it's going to be relatively narrow, right? It opens down because it's negative, and 4 is a reasonably large-sized number, so it's going to be pretty narrow. When I plug in 2, 2 squared is 4. 4 times -4 is -16. 2 times 4 is 8 plus 8. So that's going to be 0. So at 2, we're at 0, right? So we're at 1/2 away from the axis of symmetry. So we go 1/2 away from the axis of symmetry, and we have another point. And that's enough to graph our graph. Okay, so to graph a quadratic function, I'm going to find the x-coordinate of the vertex. Once I have the x-coordinate of the vertex, I'm going to plug it in to find the y-coordinate of the vertex. Once I find the y-coordinate of the vertex, I know where the vertex is. The axis of symmetry is always a vertical line passing through the x-coordinate of the vertex. Then I do 2 points to the right, match them to 2 points to the left using symmetry, and I've got my graph. So when we're talking about maximum and minimum values, remember if the graph opens up, we're looking at a minimum value, and that means that x was greater than 0. And when my graph opens down, I'm looking at a maximum. That's when x was less than 0. So remember, we're looking at a minimum when xa is greater than 0, and a maximum if a is less than 0. I tend to think of it more as opening up or opening down because it's pretty obvious. It's a minimum here. There are no y values that are less than it. It's a maximum here. But sometimes you don't want to graph it, so it's nice to know when my a value is positive, I'm looking at a minimum, and when my a value is negative, I'm looking at a maximum. So if we want to find the minimum or maximum value, do I have to graph this? No, I really don't. I'm going to find the x-coordinate of the vertex. My x-coordinate of the vertex is going to be the opposite of b over 2 times a. And that helps me find the minimum or maximum because now I'm going to take this value and I'm going to plug it into the equation. So y is equal to negative 7 halves squared plus 7 times negative 7 halves plus 8. By the way, this opens up, so we're finding a minimum value. Okay, so negative 7 halves squared is 49 fourths. Plus negative 49 halves plus 8. Now, I'm going to want to make everything be in fourths, right, in order to add these fractions. So 49 fourths plus, I'm sorry, it really isn't going to be plus, because plus a negative becomes minus, and that's going to be 98 fourths plus 32 fourths. So these two become negative 49 fourths plus 32 fourths, and that's going to equal negative 17 fourths. Okay, so negative 17 fourths is my minimum value. Okay, because when we're talking about minimum or maximum, we're talking about the y coordinate. Okay, taking a look at that in application, I've got this suspension bridge. Okay, so here's this bridge, and you know now we've overlaid a Cartesian plane onto the real world view of this bridge. Here's my parabola that goes between the two different towers of this suspension bridge. My vertex is going to be somewhere in this area here. It opens up, so there's going to be a minimum value somewhere around in there. Okay, and that minimum value will be how high the roadway is above the water, or actually the cable, which is typically a little above the roadway. Okay, and so they've given me this equation. X and Y are in feet, so I know my units of measure. The height of the cable at its lowest point. We're talking about the y coordinate of the vertex. So I know the x coordinate of the vertex will be the opposite of b. B is negative 3.7. So it's going to be 0.37 divided by 2 times a, which is 0.000097. That's kind of an awkward number. But I've got a calculator. I can do that. So I'm going to take 2 times 0.12347 equals, and I want to invert that. So I'm going to make it a denominator, I'm doing that, and I'm multiplying it times 0.37. Oh. Crap. Okay. So I'm going to take 2 times 0.12347 equals, I need to make it a denominator, so I'm going to use this key to invert it, so I can multiply it times 0.37. 1907.22. I'm going to use that, okay? 1907.22. Once I know the x-coordinate of the vertex, I need to plug it into this equation. So I'm going to have 0.000097 times 1907.22 squared minus 0.37 times 1907.22 plus 549. Okay, so if I go back to my calculator, I can take this value and I can square it, and then I can multiply it times 0.12347 equals, and I get this number, 352.84. 352.84 minus, let's go back to my calculator. 0.37 times 1907.22 equals 705.67. So 705.67 plus 549. Now that's easy. Before now it was pretty complicated. Now it's pretty easy. Right? So I have 352.84 minus 705.67 plus 549 equals 196.17. So y is equal to 196.67 feet above the water. Okay, now if I had wanted to do this another way, I could have thrown this equation into Desmos, and I could have found the y-coordinate of the vertex, which might have been simpler. You should use whichever methodology makes the most sense to you.